This screencast showcases an advanced feature of JProfiler's AI probe, the capability to categorize LLM requests according to your own custom rules. To generate live data, we're going to profile the LLM demo session that ships with JProfiler. Profiling settings contain configuration for each probe. The AI probe has its own settings too. Let's take a look at them. The setting we're focusing on for this screencast is hotspot naming. This determines how different LLM requests are grouped. By default, the model name is used as the hotspot name. Let's see what that looks like in the recorded data. The demo session makes two different types of calls. First, it analyzes 5 paper summaries from archive.org and extracts keywords. Second, it consolidates all keywords. Here we can see the keyword extraction calls with a single stack trace leading to the probe payload, which is the name of the model that the request was handled by. The keyword instruction prompt consists of 2 messages. The first is a system prompt and the second is a user prompt that includes the title and the summary of the paper. In the hotspots view, we see the single model name, which is the same for all calls. We can open the back traces and see the same reversed method stack trace as in the call tree. Now we see that the second request type has occurred. The prompt has a different structure, but the call also uses the same local JLlama model that is downloaded when you start the demo for the first time. This isn't a very useful hotspot if there is only one possible value. Other applications are more diverse in this respect and use various models, so taking the model name as the hotspot will make sense for them. For example, in the previous screencast, there were chat requests and embedding requests which used different models, and so those showed up as separate hotspots. Let's head back to the probe settings to check out the other option for hotspot naming. As in several other probes with a similar problem, such as the Kafka probes, JProfiler's script system comes to the rescue. This is a script that will be compiled locally. Then it will be sent to the JProfiler profiling agent in the profile JVM. For each LLM request, the script will be invoked to decide the name for the probe payload. The script receives 2 parameters: a script context for saving state across multiple invocations, and a model request object for accessing prompts and metadata. Clicking the hyperlink for the model request class opens the Java doc. We can see that we can query the instructions, the model name, and the request type. One easy way to distinguish between the keyword extraction calls and the consolidation calls is to count the number of instructions. If there are 2 instructions, it's a keyword extraction call, otherwise a keyword consolidation call. Let's take the keyword extraction logic further by grouping calls into buckets based on the character count. In this script, we can access all classes on the class path. For the AI probe, this is useful when you want to work with statically accessible state in the application and include it in the script. For sessions started from the IDE plugins or locally started sessions like this one, the class path is available for compilation and code completion. When you do remote profiling, you would have to add local jar files for the classes that you're using in the script. Additionally, the script allows you to exclude specific LLM requests from processing by returning null. When we apply the new settings, you can choose whether to apply the new settings immediately. If you choose to do so, all recorded data will be cleared and the active recordings will be restarted. While we're waiting for some new requests to be recorded, let me point out another setting that will be important in heavy-duty profiling. LLM calls can carry large amounts of data. If you process a lot of these requests quickly, the volume can exceed the maximum data limit JProfiler allows for event recording. To allow more event data to be recorded, go to the Advanced Probe settings and change the value for the maximum file size. In the hotspots view, we can now see the effects of our new hotspot naming script. For each distinct value, we get statistics and separate backtraces. The same description is visible in the events view, and you can use it for filtering. Being able to define ultra-flexible categories like this on the fly enables you to answer the questions that are important to your particular use case and that standard method profilers could never reveal.